Hello, my name is Brent Ferrier, and this is my final project for managing machine learning projects. In my organization, the supply chain is changing quite frequently, and it's causing a lot of part shortages in the manufacturing process, and this is leading to missed sales opportunities. The purchasing team is responsible for too many purchase orders to be able to manually review everything, and they rely a lot on tribal knowledge to prioritize that work. I believe a machine learning algorithm can help solve this by automatically reviewing all purchase orders for the risk of being late with a classification algorithm. I think that this will also allow less things to slip through the cracks because we'll be able to automatically review all purchase orders and not just what the previous human team would classify to look at based on their tribal knowledge. And does someone care about this problem? Just to put it simply, investors care quite a bit. This is a multi-million-dollar problem for my organization. The purchasing team definitely cares. This will make their life easier if it's possible. And all the way up through our directors of operations and plant managers, this is a key metric that they look at. To understand the problem through the CRISP-DM framework, first you define the problem. So my target user is a purchasing team member, and my goal is to automatically review all purchase orders. And it really matters because late purchase orders disrupt the entire factory and cause rework. And right now that rework is trying to be avoided through tribal knowledge of specific parts or suppliers, or trying to leverage the personal relationships with those suppliers to prioritize work. And there's a lot of gaps in the current state. Turnover of our experienced people causes that tribal knowledge to be lost. We can't leverage those personal networks anymore. And there's too many purchase orders out there to be manually reviewed. So for this project, we can calculate the number of hours of rework in the factory that's caused by part shortages. And just for standard accounting, we typically use it for project estimates $60 an hour. So our project goal is to reduce that opportunity bucket by 10%. And the metric for the machine learning algorithm is the area under the ROC curve. This is important because I want to be able to catch as many late purchase orders as I can, but I don't want to have too many false positives. So I need to have a balanced metric, because if the more false positives I have, the more I'm going to waste the purchasing team's time for investigation, and that's already a rare commodity. Some potential factors that could help this algorithm, a big one potentially is weather. What does the weather look like between when the supplier shipped their part to us along that route from the supplier to our factories? What does the previous supplier's performance look like? What does that previous part performance look like? Those two paradigms are kind of important because maybe the supplier is just really bad, or maybe this is just a really hard part that all suppliers are struggling with. My solution validation plan, I did a 70-30% train test split following this picture on the left. I had about 400,000 observations in my data set total. I did leave group out cross-validation, and each time I did 25 resamples. I tested 18 different algorithms. I didn't list them all here, but some of the more famous ones are random forest, neural network, logistic regression. I looked at support vector machines, decision trees, extreme gradient boosted trees. At the end, the extreme gradient boosted tree was selected as the final model. It had the best AUC on the test set. For the ML system design, I chose cloud, online learning, and batch predictions. The algorithm doesn't need to process on an edge device. This can run in the cloud, and the results can be distributed to the team through a dashboard. I chose online learning, but it's a little slower than the examples that we had in our lecture. New purchase orders are created after our material resource planner program runs every Sunday. So we'll create new predictions through that batch service every Sunday after that gets updated. But every Sunday, any open purchase order can get an updated prediction with new information that was input into our database from the previous week. So as long as a purchase order is open, we can make those weekly predictions, and as we get closer and closer to that expected delivery date, our predictions should update with the new information. And I chose batch prediction for the final selection because there's no API that needs to serve this data. The data input itself is a batch process, so it's pretty slow to update. We only need to make these predictions once a week. There are really two main concerns I have for potential risk in production. And the first is data drift. The supply chain is always changing. We're always changing suppliers, getting new suppliers. Suppliers are always changing the ways they behave. Sometimes companies merge, they split apart, and that really changes the data that's coming into the model. The other concern I have is concept drift, and this has really been seen lately with the impact of COVID-19 shutdowns. That it's just caused so much variation in the supply chain in general that suppliers don't really act the same as they used to before 2020.